to all who enter, for what you see is the mind of God. These are the words which I have put into cement, the Iadevaia Observatory, words which I use as a greeting and a thought-provoker. In this area, we have the roof control switch. I unlash the safety chain, set the roof control in its proper position, in this case down, and then I push the start button. Hopefully with this action the roof should slide off. After the roof slides down, I manually position the telescope to its viewing position. You'll notice that there is a telescope, smaller telescope, mounted on the larger one. This is 7 centimeter or 3-inch Newtonian. This is an 8-inch or 20 centimeter Newtonian. Both telescopes simultaneously are fixed on the same object. I use the observatory as a teaching aid in that with both telescopes fixed on a common object, the relative brightness can be seen through the 8-inch and compared to the 3-inch. And the terminology which you normally call light gathering power of a telescope is readily seen, and this information is conveyed to the student. This area contains the slow motion controls. I have a handheld unit which I can bring up to the observing station, and by controlling the right ascension oscillator, I can control the sweep. I can get planetary sweeps, lunar sweeps, or sidereal sweeps from this equipment. In this area of the observatory, I have a digital clock and the shortwave receiver. The digital clock is calibrated at the beginning of each observation session. The calibration is via WWV, which we use as a time standard. The receiver will also, when tuned to approximately 18 megahertz, act as a radio telescope receiver, the antenna of which you will see shortly. This switch, which is located back here, is the antenna control. When I position this in the upward position, I'm able to put in a known resistance value and calibrate the noise of the receiver. In the downward position, the antenna is put into the circuit, and whatever I hear then and measure on this voltmeter is what I'm listening to. It makes for an excellent solar telescope. This is the antenna for the radio telescope. It's called a cubical quad antenna. It consists of a reflector in the back and the driven element, which is forward. With this particular antenna and my optical telescope, I have a frequency range of approximately 20 meters up to 7,000 times 10. The radio telescope also gives me an advantage in that optically, when there is a cloud cover, you can't see anything. However, with the radio telescope behind me, I am able to pierce through cloud cover and listen to the sun on a cloudy day. Iadevaia Observatory has also one other tool which is quite valuable in my work. The digital computer is the other handy tool which we use at the observatory. Here you see the main frame, which contains 16K of memory. Behind me is a video screen, and the keyboard terminal is here. We have a remote terminal located just above me. Here is one of 2 remote terminals. The other is not built yet. The other one, when it is finished, will be directly at the observatory. The program which is now running is the telescope positioning program. Here you see a list of reference stars which I use for the positioning program. For example, I will use the star Vega as a reference at this time and enter in the object I'm looking for, being M45. As you can see in the bottom line, the computer asked for the position that the telescope was on currently.
David, what is the right ascension and declination?
Ascension and declination. Right ascension is 23 hours 54 minutes, declination 33 degrees. With that, Mary Margaret would come back with the computer-controlled answer, and I would go over to the telescope and manually position it to the coordinates generated by the computer. Hopefully the object in sight will be the object I looked for, in this case M45. You have had a brief tour of Iadevaia Observatory and seen some of its capabilities. But remember something, especially about the objects we see in the heavens. Some of the objects that you see may not even exist anymore.